Hi everyone, Assalamualaikum warahmatullahi taala wabarakatuh. My name is Khairul. Today, on behalf of my team, I would like to present our project called Condition Monitoring System (CMS) by using IoT as a training kit. So this is the agenda of our presentations. So we're starting with introductions, problem statements, methodology, product and demo, and conclusion. Introduction. Condition monitoring system is important to evaluate the current status of health machines. Most of the industry that run high volume manufacturing output will use this technology to monitor their machine health status. However, the knowledge of this technology is quite niche. Hence, the industry demands the worker to get exposure to this technology. Therefore, there is a demand for training equipment in this field. Moreover, with IR 4.0 trend, the industry also consider to adopt IR 4.0 in CMS system so they can monitor the failure stage of the machine remotely. Hence, they can make a decision faster. So there are a lot of CMS training equipment out there, but there are suffer have two problems. The first one, the current model is a complex, so they have a lot of unnecessary components. Another one is the current problem is expensive. Another reason is the current systems using the standalone software with fixed modules. In fact, the system is inflexible with the sensor array, which limited the different type of sensor for the participant or the user during training. Another problem statement is the jig have a complicated with unnecessary software features, which mean they don't need some of the analysis. Therefore, they need to pay more rather than need. Another one is lack of IoT modules. To overcome those problems, so the objective of the project is to develop CMS with the IoT solutions, and we use open source software. So this is the methodology for this project. We use replaceable components. In this project, use bearing as a components. We have adjustable motor speed load. We have the sensor to collect the signal from the machine to send the data into the CPU for processing. We have microcontroller. We have CPU to process the data, and we use open source IoT platform. All right. Applications, we design our system in CAD model and to study the, the mechanical properties. We study deflection, bending, torsion, and torque analysis. We perform the final element analysis to study the stress and strains. Based on the stress and strain analysis, so our product is safe to be used with the factor of safety more than 6.0307. So these are our products. We have the easy motor here connected with shaft and the bearings. So this bearing can replace with good and bad bearings. So we have the microcontroller here connected with the sensor to collect the vibration and temperature signal. This signal will be sent through the serial monitoring system, and we have a dashboard by using the node right to visualize the vibration and temperature signal. As you can see, there are notifications up there. The same dashboard can be monitored using a smartphone. This is another demo. You see the background calm, to the monitor.
Boleh kak?
Have the vibration and temperature connected to the body to show the vibration data to gauge temperature. So we use the open source IoT platform. The open source program are free to download by the user. We have the vibration monitoring software, temperature monitoring software, sun monitoring software, humidity monitoring software, and acoustic monitoring software. So the uniqueness of this program is that we have replaceable components and simple assembly process. And these components are ready-made defect components that are artificial defect for teaching and learning purposes. and we use the open source software for data monitoring. In fact, there are free modules that are available to the user that can be used. And another thing is that this project integrated with IoT technology to meet the ESG and ETech accreditations criteria. So this is the costing that we use for this project. We have consists of cost from SC motor, bearing, sensors, and fabrication process, which is costing us around 962 ringgit. So the target market for this product is we can use in institute of higher learning such as university, college university, polytechnic, and college kemahiran. So another target market we can use the R&D center and center. So this product give the value in terms of efficient teaching and learning equipment because the module based on demands and the simple and effective designs and friendly system. The module based on demand because the targeted components can be chosen by the user either bearing, shaft, or gearbox. And for the commercial values, the price is significantly lower than the average market price, which is costing more than 10,000 USD. It uses open source software, which allows the user to modify the system interface. In fact, if the user do not want to modify the system interface, they can update the free modules that we develop and freely to retrieve from the GitHub. And this system can export the user with IR 4.0 embedded knowledge. With our team, my name is Khairul as project leader, Dr. Farhan as a researcher, Dr. Nordin from Electric Partner to fund the project, and Dr. Agus from International Partner University Pachas Sakti Tegal. Thank you for attention. So we're looking forward for your recommendation. Thank you, everyone.